Ya, Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan kembali, my name is Muhammad Ilham Karim, and today I'm going to share my video about uh, my progress on my individual project. As you can see, I'm going to share my whole screen. Okay. So this is my individual project with the title of the effect of octane on performance and energy consumption on my BMW E36 330i. 3 is for the 3 series, and the 30 is for the engine displacement. But originally it's now 2.5 liter BMW. So as you can see here, uh, my last progress is uh, write in the formula for the octane index. And now my newest progress is I'm going to tell you specifically about my BMW specification. So in this test, I'm going to use my BMW E36 that is equipped with a knock sensor that detects the onset of slight knocking. When knock is detected, the EMS system first takes corrective action by retarding the ignition timing, and at higher engine speeds can also apply fuel boost to lower exhaust temperatures. These measures protect the engine from damaging impacts but reduce horsepower and acceleration. While the value of K equals to 0.5 was still a good estimate until the early 1990s, more recently prepared compounds have much lower and often negative K factors. And this is the reference I put in here. And from the reference, it confirmed that this trend also applies to miniaturized servo motors representing future production. In other studies, on these medium studies written by Mittal and Haywood on 2008, and on 2010 written by Rimert et al., that octane response has been shown to vary slightly between performance measures and under different operating conditions. But the general trend for negative K values is that RON is operate more favorably than MON in fact exists. MON can actually have a detrimental effect on engine performance. So this is the graphic. I'm not putting it on the wiki yet, but I'm going to put it in. So this is the K value. This is the graphic for the MON test that defined. And this is the US road octane. I get it from website. And this is, we're going to use this graphic as our literature studies in this year between 1992 to 2010. And from this graphic, it states that K is negative in most modern cars tested. So it is now widely recognized that transport must simultaneously consider fuel production and vehicle efficiency to minimize energy consumption and CO2 emissions. In the future engine, designers may use higher octane fuels to improve fuel economy through higher compression ratio increases and other techniques. And this must be balanced against the additional energy required by the refinery to produce a higher octane rating. So, the optimal octane number for future fuels will be discussed, and getting the right balance between RON and MON is definitely part of the process. However, this consideration of possibilities of future vehicles cannot be addressed by testing vehicles in the market. The aim of this lecture was to expand the existing database of published full throttle acceleration tests for new vehicles complying with Euro 4 emission limits, and these results will compared with RON and correlated with oxygen content. So I'm not testing my BMW yet, but I'm writing the introduction for the test vehicles. So while the plan focuses on the impact on existing vehicles, future discussions may consider the possibility of retrofitting vehicles to improve efficiency where high-octane fuels are available in the market. In this test, the procedure of the BMW E36 is tested against Euro 4 emission limits. The BMW E36 is an upper middle class passenger car with a naturally aspirated 2.5-liter direct injection engine optimized for 98 round fuel. And also this car is equipped with a manual gearbox and a three-way catalytic converter as well as a knock sensor. For the test, I'm going to make the video in the next week. So don't forget about my progress. I'm going to tell you guys soon. Thank you.